All right, we're continuing on day 37. We were on letter C. This is on page 92 in your notes. We're dealing with orange circumferences, so I'm just going to draw that normal curve quickly again. This is orange circumferences. Our mean was 20 centimeters. And then our standard deviation was 4, so we put our marks 24, 28, 32, and then 16, 12, and 8. All of these are in centimeters. I draw my marks at 60%, and then a fourth of the way up, or eighth of the way up, sorry, on the second standard deviation. Okay, so now what we want to do is we want to know what is the proportion that are greater than 25. So the best way to start these problems is to say, what's my variable? What's x? X is the circumference of any given orange, of an orange. Okay, we're going to randomly select an orange. And what is the probability that it is greater than 25 centimeters? So what we have to do with 25 is we need to change it into a z-score. So this would be the probability that z then becomes greater than, well, what's the z-score? To calculate the z-score, we take the observed value, 25 centimeters, and we subtract from it our mean, which is 20, and we divide that by the standard deviation, which is 4. So we are looking at the probability that the z-score is greater than, let's see, 25 minus 20 divided by 4. Take 25 minus 20, hit enter, and then divide by 4. And that gives us our z-score is 1.25. So what is the probability that in this distribution our z-score is greater than 1.25? Okay, so here's the deal. Whenever you're dealing with a normal distribution, you're always finding the area shaded to the left. Okay? So the picture that we drew over here, okay, the area to the left is what the z distribution table finds. So if I'm back on page 91, the standard normal distribution finds areas to the left. Okay, it finds areas to the left. So the left of something, it finds areas less than something. All right, so and it actually shows that in the picture I'm going to show you in the distribution. See how it shows here here's your z-score, it's shaded to the left. So it's showing you that all of these values are less than values. Every one of these are less than the z-score. Over here, here's a positive z-score, it's always shading less than. So if we have a greater than problem, we really have to think, we can find the less than. Basically, the probability, the proportion, the percent that will be greater than a z-score of 1.25. Here's the 25 centimeters on here. We're looking for this shaded here. All our normal distribution will find for us is this. So all we're going to do is take 1 minus the proportion of z-scores that are less than 1.25. So we're going to find it by using the complement. So I'm going to go on my normal distribution. I'm going to find a positive 1.25 z-score. So here we go. Here is a 1.25, and you find where they meet, 0.8944. That is the percent shaded to the left. Okay, so 0.8944 is the percent shaded over here. So that part, the less than, is 0.8944. We need to take 1 minus that to get our actual percent that we want. And that is the proportion of oranges that would have circumference greater than 25 centimeters would be 0.1056, or 10.56%. All right, so what proportion have circumferences between 17 and 19? Okay, so this one takes just a little bit of work. So what proportion have circumferences between 17 and 19? I'm going to use this picture right here. So between 17 and 19, first of all, let's think of 19. Okay, so if I were just finding the proportion, well, between 17 and 19, it's going to be like this little section right in here, 17 to 19. Okay, so now knowing that the normal distribution only finds areas to the left or less than areas, how would I figure this area in between here and here out? Well, it's actually pretty easy. If I just took all of the area less than 19, so if I took, to find the area between 17 and 19, and between any two values, it always is going to work the same. You're going to take the bigger one, okay, so you're going to find the proportion of values that are less than the bigger one, okay, and then, so if I've got, I mean, if you just think of it this way, here's 19, I'm taking everything over here below 19, okay. Now what I need to do is I need to take everything below 17. So here's 17. If I take everything below 17, that'll be the proportion of values that are less than 17. And then to get the area in between these two, I just subtract those. So you always take the proportion of the bigger one, less than the bigger one, minus the proportion less than the littler one. And that's how you do any in-between one. Okay, so now I need to find the z-scores for each of these. So the z-score for 19, so 19 minus 20, the z-score for 19, 19 minus 20 divided by 4, and the z-score for 17, 17 minus 20 divided by 4. So this z-score will be 0.25, so this will be the proportion of z-scores that are less than 0.25, minus the proportion of z-scores that are less than, let's see, 17, oh that should be negative 0.25, sorry, negative 0.25. And 17 minus 20 is negative 3 divided by 4 is negative 3/4, negative 0.75. So the proportion of values that are less than negative 0.75 and subtract those. So I'm going to go to my z distribution. I'm going to find the z-score of negative 0.25. So negative 0.25, I'm on this page, I'm on the bottom. So negative 0.2, go over to 5, find where they meet, 0.4052. So that is 0.4052 minus, now I'm going to find the z-score of negative 0.75. So negative 0.75, find where they meet, 0.2296. Oops, not far enough over. Sorry, I need one more over. Negative, or sorry, yeah, not negative. The z-score for negative 0.75 is 0.2266. So 0.2266. So in other words, there was 40% shaded below the 19 and 23% shaded below the 17. I subtract those, 0.4052 minus 0.2266, and that is 0.1786. And that would be the proportion that are between 17 and 19 centimeters. All right, so now we're going to do things a little bit backwards. Now what we're going to be looking for, instead of looking for percents, we're looking for values at the bottom. So now it's like they're saying, okay, if you shaded this much, okay, so in my distribution, I'm just going to redraw it. So here's 20. Again, you are going to be drawing a lot of normal distributions, so you might as well just get used to it. It's how you show pretty much everything on the AP test. I mean, this normal model is what we're going to use so much for the rest of the year. So we want to know what is the 90th percentile. Now the 90th percentile you might not think relates to everything we just did, but we just actually found a whole bunch of percentiles. This answer, 10.56 from earlier, for part A, the proportion of oranges that have circumferences greater than 25 centimeters, that's a proportion. That's a percentile, okay? It's up here, 10% or greater than that. So I'm going to flip the page back to where we had that picture. So basically we found that about this is 10.56% are greater than 25. Okay, so about 89.5% are below that. Okay, proportions, percents, same as percentiles. So all we're looking for now, here's the thing, they tell us this is how much I've shaded. I've shaded 0.90. This is the percent. This is the proportion. Now, so they tell us we have a certain percent or proportion that we have shaded, and we want to find what number from down here, how many centimeters, question mark centimeters, represents the 90th percentile. Okay, so the 90th percentile means 90% are below this. Okay, so we need to figure out, okay, if I shade this, and I've shaded 0.9 or 90% of this, what number down here will it go with? So we're basically working backwards with our z-scores. So in other words, it's not the z-score, we know that the proportion is 0.90. So I need to start with my proportion of 0.90. Step 1, find a z-score for it. So I need to work my way, it's like I'm doing these other problems completely backwards. So I need to find a z-score for 0.90. So 0.90 is above, it's up here above the 50th percentile. So I'm going to look for a positive z-score. So my z-scores go to 4 decimal places. I need to find the one that's closest to 0.90. So I just start looking along, and there's a lot of them that are 0.90. So I just want to keep going. There's 0.9015 and 0.8997. And I would say that's closer to 0.90. So the z-score that goes with that, if I go over, is 1.28. So the z-score that went with, find a z-score for 0.90, and that z-score we found was, I believe, 1.28. 1.28. So that's our z-score. So find a z-score for 0.90, that is 1.28. Okay, so the answer to that is 1.28. So now what I know is I know that the z-score for this, I'm just going to kind of work this one out down here. So this is going to be part E. So I know that the z-score for this is 1.28. All right? So if I set up my z-score equation, z equals x minus mu divided by sigma, the z-score I know that I want is 1.28. I'm looking for this x value. This is what I'm looking for, what value along here. So I'm looking for this. I know my mean of orange circumferences is 20 and the standard deviation is 4. So now I have this equation, I can just solve it for x, and now I'll have my answer. So 1.28 times 4, so I'm going to multiply both sides by 4, and that gives me 5.12 equals x minus 20. And then I'm just going to add 20 to that, and that gives me that the x value is 25.12 centimeters. So the 90th percentile, 90% of oranges are going to have circumferences less than 25.12 centimeters. Okay, so now another question almost exactly similar, except we're asked for the first quartile. The first quartile is the 25th percentile, or the 0.25. So we start with 0.25 and find its z-score on table. Okay, so we start with 0.25 and find its z-score on the table. So 0.25, let's see, the 25th percentile, the picture-wise of this, where would this be? Well, this is 50%. It's going to be like over here in the negative. The 25th percentile is down here in the bottom half, so I'm looking for a negative z-score. Okay, if you're below 50th percentile, you're looking for a negative z-score. So I need to find the closest thing to 0.25 on my distribution. So here's, let's see, 0.24, 2483, 24. Here we go, right in here between 2483 and 25. I think 0.2514 is closest to 0.25. So that would be negative 0.67 would be the z-score. So the z-score for that was negative 0.67. Now I set up equation with z-score. So the z-score is z equals our x value, which is what we're looking for, minus the mean divided by sigma. The z-score we had was negative 0.67. We were looking for what x value that was. Our mean is 20. Our standard deviation is 4. Once they give you that mean and standard deviation at the beginning, that's what we're using for the whole thing. So now to solve this, I'm going to multiply negative 0.67 times 4. And that gives me negative 2.68 equals x minus 20. And then I'm going to add 20 to that. And that means that the orange circumference of 17.32 centimeters is going to be at the 25th percentile. Okay, finally the interquartile range for this. The interquartile range for this distribution, well, that is Q3 minus Q1, which is the 75th percentile minus the 25th percentile. And I'll finish this on the next video.